There are two parts in the question. You're given planes in vector form, parametric vector equation of the plane, parts A, part B, two different planes. You have to just convert these planes into the Cartesian form. I'll do part A. Part B, obviously, it will be a good practice for you to seal this technique in your heads. So I just nothing much to think about here. We have just followed this procedure I outlined for you in this general discussion in the previous slide. Look at this. What we do, we first give the names to the components of my x vector. I'll follow the traditional path, x, y, z for that. Here it is. Now, the next step will be equating the x, y, z column to these three columns together. Here's my equation. Left-hand side, x, y, and z. Right-hand side is -3 double lambda negative mu. These are the components here. -3 lambda times 2 mu times -1. Second line of components, it is this 2, this 4 times lambda and no presence of mu because of the 0. And the last one is 6, no lambda and 3 of mu. If I equate this if I equate these components individually, is the expression for x. Here's the expression for y. Y equal double plus 4 lambda. And here's the expression for z. Z equals 6 plus 3 mu. The next stage in my process is this. Remember, I have to choose two equations, solve for lambda and for mu, and then put the solutions into the third one. I think you don't have to have much of the intuition to suggest which of those two we have to choose in this case, right? The last two is a very clear choice for the solution because the solution is immediate, isn't it? Are you with me on this one? It's not a big deal to choose this time. But the last two, as those two we have to focus on first. So here's my solution. If I solve for lambda from here, that will be the expression like this, right? This 2 goes on the left-hand side, and I divide everything by 4. If I solve similarly for mu, that's the kind of expression I will come up with. Now, these two, they go in here. These two, they go in here. This is the place where I did that. So x is the left-hand side. Then goes -3. Nothing changed with the -3. 2 times the expression representing lambda, and then negative the expression representing mu. That's exactly what I was this is exactly what I was telling you when I said we have to substitute the solution into the remaining equation. This is the result of that. You can simplify this, of course. I hope you can. There are this -3, -1, and +2 together will make -2. You can bring everything on one side. The result of these transformations will be something like this. This is the Cartesian equation for the line in part A. My coefficient A is 1. My coefficient B is -1/2. My coefficient C is 1/3. My D is 2. And that's all there is to this example.